Hey everyone, it's
Hello.
Alfred,
Sumrine.
and welcome to our live stream. This is episode 111, and in this episode, we're going to be showing you how to make a matrix voice controlled light switch using Snips.ai. So yeah, we'll get right into it basically. So what we're going to do is we're going to use a matrix voice, and it's going to be connected to a relay. So a relay, it's basically, well, what's a relay?
It's kind of like a switch. Like, it's basically in it, it has like an electromagnet kind of. So it has like, say, these two wires. One is connected and one is not, and this is the signal. So if you like say turn this on, it'll switch to here, and then say this is completing a circuit, and then when it's off, it'll switch back to here, and then it breaks the circuit. Yeah. So, it either completes or breaks the circuit.
Yeah. So you're electronically controlling that through the Raspberry Pi, and this allows you to control voltages like the 120 used for light switches in the US, or 240 in Europe and most other rest of the world, by using a Raspberry Pi. Because if you were to just give the Raspberry Pi 120, it would die pretty quickly. So we'll get right into it. Oh, another cool thing. For this guide, unlike our other guides where we normally are showing you like how to use Snips, how to set up Google Assistant, this is actually like a real project and complete with a 3D printed case that we designed. So here, I'll show you guys the case. So here's the case. Raspberry Pi sits right here. This screws right into like the light switch, so this would be like replacing your light switch at home, work, wherever. The wires for the relay would be inside the box, inside the wall of the light switch. They would go through this hole here, go into the matrix voice, and then this cover just slides on and screws in on the sides. Yeah. So yeah, without ado, we'll start with the guide.
Awesome.
So let's switch cameras, and I'll get the keyboard. What's the key combo?
Oh, there's no key combo. We just go whoop.
Oh, okay, that works.
Yeah.
Easier. Cool. So this is the guide. So this is the guide that we are about to publish on Hackster. If you're seeing this right now, you won't be able to see the guide. But if you're seeing this after the live stream has happened, then the guide will be live on Hackster, and you'll be able to follow it on your own. So here it is. You can use a matrix creator or matrix voice, a Raspberry Pi, a relay, of course. For the light switch case, we only designed it for a matrix voice. We might be coming out with one for a matrix creator in soonish, but let us know if you really want one, and that'll incentivize us to get it out quicker. Required hardware: Raspberry Pi, matrix, micro SD card, so on. Software, we'll be using Node. We'll be programming everything in Node.js, JavaScript. Your micro SD card for the Raspberry Pi, you'll flash it with Etcher, and we'll be using the SAM CLI tool on our local computer. So we'll get ahead with this. So we've already set up our device here with Raspbian Stretch Desktop. It has already Matrix Core installed, the JavaScript dependencies installed, and Snips.ai installed. So you can either, if you're following along at home, then you'd have to do this on your own, and then we'll continue to the next step. So the SAM CLI tool, that's a Snips CLI tool that allows you to basically like upload assistants to your Raspberry Pi and then see like what's happening. Oh, what's happening? What happened there?
No idea. I'll check on that. You can continue.
So we have another light switch set up. Maybe it heard me. Hey Snips, turn on the light.
Oh wow! Live demo right there. Unexpected.
I'm so happy. Wow. Wow. That's okay.
That was beautiful. All right.
Great. So we'll have to be careful then when we're talking, because that is running, or maybe you can log into it and kill the program so it doesn't keep doing that.
Yeah, I'll check what the IP is.
Yeah, it's light-switch.local.
Okay, awesome.
Yeah.
That's great.
Yeah, it's because that's my Raspberry Pi from home. Okay, so yeah, we'll go onto our computer's terminal. Open this up and put this on the side here. I'll put this here. Scroll back. 3 more. Okay, so step number 1 is SAM. So we've already logged into SAM. You can see here. Well, don't look at my email. No, it doesn't matter. SAM login, then SAM connect to the Raspberry Pi. So in our case, SAM connect. I think we already did this, but we'll do it anyways. What was the IP? 154. Awesome.
Yeah.
Cool. Give it a second. So Pi, enter, enter. The values are already preloaded for you. So if you have the default, like Pi as the username, Raspberry as the password, then you can just press enter. You don't have to type it. And now it's connected. So we can check SAM's status, verify that everything's running fine. Yep, all live, it's all running, so we're good there. And then you can also see SAM Watch. So SAM Watch is basically a live feed of the MQTT basically log from the device. So if I tell it, hey Snips, you can see here that wake word detected, hey Snips, and then nothing else. And then it goes away. So yeah, so because we don't have an assistant on it. So that's all working. We're good there. I'll get out of SAM Watch for now. And then we'll go on to creating assistant.js. So we're going to make 3 files on the Raspberry Pi. Assistant.js, Everloop.js, and relay.js. And this is just to keep the code organized and so that we can communicate and it looks prettier. So on the Raspberry Pi, which I'm already SSH'd into, if you don't know how to SSH, you can Google that pretty easily or look at our previous guides where we can show you how to do that. So we'll already CD'd into the js-matrix-core app. This is a directory that you install when you're setting up JavaScript on your device, JavaScript for Matrix Core on your device. And then we're going to make these files. So I'll just touch assistant.js, relay.js, and everloop.js. Okay. And then we're going to need to install MQTT. So npm node package manager install MQTT -- save. That way, if you transfer this to somewhere else, it knows to automatically install it. So we'll let that go, and in the meantime, I'll open up our documentation, docs.matrix.1, just so we have that up and running. I'll go to the Matrix Core part, JavaScript examples, and I don't recall what was the order that we did this. We did Assistant, or we did Everloop first. So Everloop in our JavaScript examples. Okay, MQTT is installed. So now we'll go on to the next step. So so you can either do this through. We're now going to edit the code in the file that we just made, and you can see we have the files already here: assistant.js, Everloop.js, and relay.js. Hello World, node modules, package, and package lock, those were just already there. Hello World is something we added, but the rest just comes with the JS Matrix Core app file directory. So now we'll use CyberDuck in order to access the file on the Raspberry Pi and be able to edit it locally in VS Code. We do this because, well, Nano on the through terminal is not the best. So we like to do this because it's prettier and it lets us actually edit the file locally, and then CyberDuck is really nice. When you press save, it uploads it back to the Pi. So we'll put this in here, 154 Pi Raspberry Connect. Give it a second. There we are. Go into JS Matrix Core app and see, here are the apps that we just created: 612, 614. So we'll open the 3 of these. So Assistant, Everloop, and Relay. Command K, which just opens up the default text editor. In our case, VS Code. And there we go. So I'm going to put that there. Okay, so first step is the Everloop.js. So I'm going to go through this. I can either do it manually or I'm not going to copy and paste it all in one go. I'll like show you what's happening here. I'll go step by step. So here are the variables that we are declaring. Put this back up here. So 0MQ, so we're requiring 0MQ because that's what the matrix device uses to communicate. That's what our libraries use. Matrix IO, so that's like our libraries in order for you to like communicate with the Raspberry Pi itself, with the matrix voice itself or creator. The matrix is local IP because basically what 0MQ is, it's like a local server, which is how you like connect to all the sensors on it, the LEDs, the GPIO pins. And so you'd be connecting to the local, like internal IP of your Raspberry Pi, not the network IP, but like the physical device. Then the base port, so that's like the port in order to access the Everloop, which is like the LED ring on the device. The amount of LEDs, which this will be automatically populated. We have a function in order to get that, because if you have a creator or a voice, they have different LED counts. Methods, that's just going to be used in order to be able to access this file from assistant.js. Waiting toggle, so that's just going to be waiting for like the Everloop, because we have to set the Everloop and it's doing some cool stuff, so you'll see. And then counter. Okay, next is the keep alive port. So this is a super simple thing. It's really just 3 lines. It's creating a variable, pinging the 0MQ socket. It's then connecting to the matrix's IP and the Everloop base port. And then it's going to just send one ping once. That's all is needed. That way the device knows that like, hey, I'm here, I'm alive. Then the error port. So if there's ever any error, I mean, when you're doing things with the LEDs, the likelihood that you'd ever get an error is insignificant. But you put it anyways, just be safe. So again, you know, creating error socket variable, connecting it, or object, my bad. Carlos will get mad. No, we're subscribing to it, and then if anything ever comes up, it'll just do a console.log. Next is the data update port. So the data update port is basically how we update the LEDs on the matrix creator or voice. So it creates another object, update socket, connects to the IP with the right base port, it subscribes to it, and then when it receives a message, so wait, extract message saved. Oh, actually, my bad. Yeah, so this isn't how we give it info, this is how we get info from it. So remember how I was saying up here at the top, where there's like matrix device LEDs 0, this will dynamically give you like how many LEDs are on your matrix device. So in the case of the matrix creator, there's 35. In the case of the matrix voice, there's 18. And then the base port. So this is the fun stuff. Oh, no. Let me, okay, copy, paste. Okay, this is a good amount. I'm gonna make this bigger that way. Okay. So here's the base port. So again, creates another object, config socket, connects to the right IP and port locally. Then it creates an image object, and this is basically where it's an array that we're holding all of the LEDs of the device. So let's say you want to make it like red, white, red, white, red, white. It's just an array, so like number 0 in the array would be red, 1 would be white, and so on. So we'll be creating a set interval, and then if waiting toggle equals false. So waiting toggle here. Well, let me add this stuff on the bottom as well, because that'll help explain this. Okay. So I'll start off with this part then. So the waiting method. So basically, when in the assistant.js, when we're going to hear it say like turn on the lights or turn off the lights, that is then going to call this file, and it's going to either call the method start waiting or stop waiting. And that's how you're going to get this cool like arc reactor pulsing effect on the device. So you know like when it's here, when it's heard a wake word and when it hasn't. So that makes waiting toggle true. And so if waiting toggle is false, it basically just makes all the LEDs white. Well, correction, blank, like 0, so nothing. Turned off. and then if it's true, then it does some math here for the blue LED specifically, so that it basically does this cool pulsating effect. It took me a while to figure out this, so I wasn't best with sine, cosine, so on in math in school, so this took me a bit to figure out, but you can check it out if you want. And then counter here in order to like keep going, sends the config, and then this is like sending it. So that's it for this. So now let's go over here. Let's go to the relay. So again, the variables, I'm going to copy the whole thing this time. That way I don't have to keep going back and forth. Oops. Come on. Okay. No. Give me 1 second.
Yeah, the scrolling thing with...
Yeah, the trackpad. I should have brought my mouse. Whatever.
It's all good.
Yeah.
Nice.
Copy. Okay. So, relay. So in this file, this is where we're going to be doing a similar thing to the Everloop, but instead of connecting to like the local Everloop server and port in order to communicate with the LEDs, we're going to be connecting...
Do you want to speak a little louder?
Oh, I'm not... Okay, yeah, sure. Yeah, so we're going to be connecting to the relay one. So for the GPIOs. So here we have like the base port for the GPIOs. You can see over here on the Everloop one, it's 221 then. Here it's 249, or 20,049. So again, keep alive port, similar thing. Error port, similar thing. The base port on this one, instead of it basically sending it the LED value, it's going to be sending it like what pin you're using. So that's declared up here, so relay pin. So depending on what GPIO pin you're using on, oops, can you see this? Yeah, maybe. Here, let me get this one. So on the front of the voice, there's these GPIOs. Some of them are like 5 volt, 3.3 volt, ground, and then other ones are ones that you can communicate with. So, you know, give it a 1, give it a 0, do other things with it, whatever you want. So, we're going to be telling it to go to number 0, which is the top left one. And in the base port, it gets that pin, it gets the mode, so it's like outputting the GPIO value. And then the actual value that it's going to give it. So by default, it'll just be 0. And then over here, we have the on and off methods that will be accessed from the assistant.js file. And when it gets called lights off, it'll set the value to 1. And this will depend on like your relay. Some relays and how you wire it, 1 will be on or off, and 0 will be off. Or vice versa. You can, this is a very simple trial and error that you can check with, or look at the data sheet. That works too. So the output value sends it into the config socket and then logs it, and does the same thing for lights on. So that's relay. Now assistant. So let me go here. Copy. Okay, so this is the file where we're going to be actually interacting with Snips. So up here, something different is we're requiring MQTT. So MQTT, it's similar to 0MQ. So 0MQ is like what's used on the Matrix Creator and Matrix Voice in order to communicate it in the Matrix Core library stack. MQTT is how we communicate with Snips. And that's also what Sam Watch uses. So there's that. We're requiring the relay and the Everloop. That way we can access the methods that we exported from those. You're going to want to put your Snips username here. So in my case, my Snips username is AlfredGG. In case you forgot what your Snips username is or don't know or whatever, in the Snips console at the top right, it tells you what your username is. And later on, I'll show you where it tells you as well. So For Gigi, the wake word, so this is basically the MQTT data that we'll be listening to in order to check if the wake word is detected. This is what we'll be listening to see if the session has ended, because you don't want the lights pulsating the whole time. And then this is the intent that we're going to create on the Snips console in order to hear, well, know if somebody has said lights on, lights off, so on. So over here on connect, so we'll connect to the server. We'll subscribe to these three things. And then on message. So when we get a message, we'll parse it. And then we'll have a switch statement. So in the case that we hear wake word, like the wake word thing that we subscribe to, the MQTT thing that we subscribe to, if we hear that, then it'll make the Everloop start waiting. So it calls the Everloop file and starts the pulsating effect, and then logs it. And then down here, there's like the session end, so stops waiting. And in the middle is the light state. So if it gets light state, it will try to check if the basically if the information within that message in slot 0 raw value is on, or if, well, else would be if it's off. So it'll if it gets on, then the relay.lights on, Everloop stop waiting, because that way it stops waiting, it doesn't wait for the session to end, and then console.log lights on. Else it'll turn off the lights, stop waiting, so on. And then this is like just a little error catch, because let's say it hears like the wake word, and then hears you say activate the lights, and that's not something you've configured. Instead of it erroring out your program, it'll just, or like causing it to turn off the lights, it'll basically just get a on-off state. It'll just console.log it. And so that's it. So I'll save that, save that, save that. And let me go over to the Hackster guide. Okay, so that's basically it for the code section. Now we'll get to the Snips console. So you'll want to log into your Snips console. I'm already logged in here. You can see like other assistants I have here, some like test ones, potato. So we'll create a new assistant. This one will be called light switch. Language, English, or whatever language you want, and create. Okay, that's it. Scroll down, and now we'll add an intent to the app. So, well, first we'll create an app. Create new app. We'll name the app. We'll call it Lights, let's say. You can add a description or not. And then we'll open the app. We'll edit the app. And now we're here where we can create intents. So intents is basically how Snips knows like what you're telling it, because it has the wake word that just works. Right now the default wake word is just I don't want to say it, but it's that HEY Snips. And so it gets that, but then it needs to be able to know what to parse in order to, like, you know, create an action out of it. So we create a new intent. We are going to call it light state create, and then we're going to add a new slot. So light state, it's well, here. So it's going to be a bunch of examples of what it's going to be looking for. So turn off, turn the light on, turn off the light, whoops, the lights, so on. You can give it more than this. You know, the more examples you give it, the better it'll be. But those are just like simple ones for now. And then we're going to create a slot, because you see here I had turn off the lights, turn the lights on, and turn off. It'll know that it's heard this, but then it doesn't know, okay, what's on, what's off. So how we do that is creating a slot. So we create a slot, we'll name it power, and then the slot type will be power. So I already have that made here, but we'll edit it, and it's basically this. You have to name it up here, and then you have to add the two slots. So I'll just delete this really quick so you can see. So we'll create a slot on and off. Now, if you're making something more complicated, you can add synonyms to this. Like this could be activate. Yeah, this could be disable. It's whatever you want, and you can make this super complex. Snips has made like a really good interface for this, so you know, go at it.
Check out our last live stream if you want to hear about the tech.
Yeah. We'll go close here. Done. And now, in order to tell it like what part of this message is the slot, all we have to do is double click on the word. So we'll click power, double click again, power, double click again, power. Okay. And now we'll save this. There was a problem. Intent name already. Oh, ha 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 ha. It's because I've already made one called light state.
Oh, wow.
My bad. Intent settings. So I'm going to call this light states. And then we'll change the code in a second in order to correct for that. Okay, light states. So here, before I forget, let me just change that in the code. That would be an assistant. And the only place you have to change that is right up here, light states. So this is the intent it's listening for. So let's say you call the intent light switch. This is what you would change in order to have it work. So we'll save that and go back over here. So if you have the window a little larger, come on, what's wrong, Chrome? Okay.
Yeah, it's just...
Okay, Chrome is bugging out. Strange. No problem. So save. It's already been saved. And then here on the right, you can test it. So let's say lights are on. Turn on. So it loads, and then this is basically the JSON message that it outputs, and is what you'll be reading in the assistant.js. So the input. Turn on, the intent, it detected the intent name, Alfred Gigi, light states, probability 1, so it's for sure, it's very certain. And then the raw value of it is on, and the entity in slot. So notice, the only training example we gave it was turn off, yet it did detect on because of the slots. So, let's see, how far ahead of step 4 did I get? I've done this a lot of times, so I don't really need the guide. But just so you guys know where we are, we have this. Okay, we did that. We saved it. Okay, so now we're going to deploy the assistant. So we'll go back to the console, and on the bottom right, you click Deploy Assistant, and you just copy this command and paste it into your local computer's terminal. So we go over here. And let me just clear that real quick, and enter. So now, locally, the computer is going to basically compile the natural language process, well, understanding training, and all that, and then it's going to send that to the Raspberry Pi. And this is done because Snips is an offline voice assistant. It doesn't require an internet connection in order to work. Which is amazing, and you know that's huge for privacy, because then you don't have to. It's not like Amazon or Google where you're sending them your voice data all the time, and you know who knows what they're doing with that. So, okay, it's ended. So this little error, you may get this. I guess we have an old version of pip, which is going to be deprecated. This is fine. It'll still work for now, but you should probably update that if you get the same error. So now we'll do Sam watch so that we can hear it. Well, see the logs. And now, if we did everything right, fingers crossed, it should work. Well, so it's not connected to the relay yet. And are you able to see this? Or here, let's switch it to be the front one.
Yeah. So
this way? Right. Here we go. Cool. So, hey Snips. Is it running?
Oh, the light state thing, maybe?
Oh, yeah. Ha! I forgot one thing. See, I should be following the guide.
So, you want to switch back to your computer real quick?
Yeah, I'll switch back to the computer.
Yeah,
Thank
awesome.
you. Okay, so, Hackster. So we deployed the assistant, and then, oh, it says now to do the wire. Okay, well, I'll follow the guide. It's easier. It's easier for you. Okay, so now we'll connect it to the relay. So I'll bring the relay back up. So relay, this is what a relay looks like. This end over here is where you connect the mains power. And then this end over here is where you connect to your matrix voice. So you have like VCC here, ground, in. So VCC is like power, 5 volts, ground is ground, and then in is the signal. And then over here, which, hold on, there's a nice graphic on here that explains this. Yeah, over here. Oh, by the way, when you're doing this with your light switch, make sure you go to your like home or apartments or whatever breaker, so like the big panel that controls all the electricity, and turn off the electricity for whatever light switch you're doing, because it's 120 volts or whatever voltage you're at, and it's not going to be nice if you accidentally touch that. So make sure you do that. We're going to demonstrate this here with this lamp here that I have spliced part of the cable. So we can test that with, and we don't need to turn off the breaker because we are just not going to have the lamp plugged in while I'm touching the wires. So over here, if you read this, it basically explains how the relay works and how if you connect to one side of the relay, it will be, basically how you connect the wires from your light switch to the relay will default what it's going to do. So if it's getting no power and you connect it one way, the light will be on. If you connect it the other way, the light will be off. And basically you always want the COM side connected. And then either the left side or the right side will be that it's on by default or off by default. So what we're going to do now is switch this over to the other camera, and then you'll see me do this. So I'll move the camera down. So here we go. Slightly messy. No issue. Okay. So got the matrix voice here, got the relay here, and we have this light bulb here. So here, I'll put the matrix voice to the side for now. And we have the relay here. So we have this light bulb, and we have these 2 wires spliced from it. So this is just a surrogate for what an actual light switch would be, and it's easier for us to do for now. So on the relay, I'm going to connect it to which ones? Here, let me get this so it's easier to point. So I'm going to connect it to this one and this one. So this is like the COM one, and this is going to default it to being off. Because, if this restarts in the middle of the night, you don't want your lights to be turned on. That's not fun and wake you up. So this is super simple. You just put the wire in. Doesn't matter which wire you put in which one, so long as you're putting them in the ports that you want. So we'll put one in here, and then we'll tighten that. Okay, that one's good. And we'll put this one in here. And screw that in. Okay, now this is a really important thing to know. See the bottom of the relay? It has all these contacts exposed. This is going directly to the power. So what I do, and you should do this too, is get some electrical tape and tape this thoroughly. That way you don't accidentally electrocute yourself. Now I'll typically, take a little bit, I'll cut these and spend some time making this really pretty, but for the sake of the live stream, I'm just going to cover it a little bit, just, for expediency. And these are really, the really big ones are the ones you want to cover. You should cover these too, but if you touch these, it won't hurt you. These are the ones with the big voltage. Okay. So that's done. So now you notice our relay board here is actually a 2 relay board, just because we couldn't find a 1 relay board fast enough. But it's the same thing as a 1 relay board. The only difference is that it has this extra set of 3 pins here, which basically makes it go. It's a voltage thing, so you can give signal like a different voltage than what you're powering this with. So we're basically jumping this one to this one. But if you have a 1 relay board, then you won't have to worry about this. And then over here, we have it connected to power, ground, and then the orange cable is the signal for this relay over here. So what we'll do is we'll get the Matrix Voice, oops, and we'll plug this into the front of it. So power, the red cable, goes into the 5 volt, which is all the way at the bottom, the second row on the left. And then ground, brown cable, is all the way at the bottom underneath that. And then pin 0, which we assigned before, is all the way at the top. Okay? So that's it. Now, of course, you can change where this is, but you then have to change this in the code. So this is all wired up already, and we should be good there. So now I will plug this in over where? Let me see, where's the... Thank you. Okay. So let me put this over here, put this over here, make this a little nicer. So when you are using the case, as I said in the beginning, this will get screwed into the wall, and what you should do is, completely take out the light switch that you're using, take out the wires, be very careful. Your light switch may have a ground, like a green cable. You don't have to really worry about that, and you just need the 2 live wires. So you would want to put the relay inside of the box in the wall for your light switch, and only have these 3 cables coming through this hole here, and then connecting to the Matrix Voice. By the way, something nice about the Matrix Voice, the GPIO ports on this are through hole. So from underneath it, you can connect the GPIO wires, and they will still work just as fine. Just make sure you're connecting it to the right part. And that way, when you have it in this case, the wires aren't poking out from the front, they would be underneath, and you're good. Okay, so now, to get this, so what's next in the guide? Let me switch over to the screen. So disconnect the wires, be sure you're doing all that, printing assembly of the case. So this case we designed, and it's a nice case. If you have any modifications you'd like to make to it, let us know. The files are available here. We have them on GitHub. It basically, your Pi would screw into these posts here. This is where it screws into the wall. And then this is where the actual top of the case screws into the back. Okay, that's how it looks on a wall. It's cool, right? So you can see the microphones for the Matrix Voice, they're all exposed here. Da, da, da. And the LEDs, it looks really cool. I set this up in my apartment this past weekend, and I was very happy with it. One future thing that I may do, because the walls of this are, I think, 2.5 millimeters thick of the case, so the LEDs on the Raspberry Pi actually shine through the walls. It's not bright, but it's noticeable, so what you could do is just like electrical tape over the LEDs, and that'll cover that.
That's it for the hardware.
Yeah, so that's it for the hardware. So now we go over here to the Raspberry Pi, and we want to start the program. So we do node assistant.
First, we would change the light states because you named it different.
I did already.
Oh, you did?
Yeah.
Oh.
Yeah, immediately after. That way I wouldn't forget.
Oh, very nice.
So we start the program, node assistant.js, connected to the Snips MQTT server. So that should be good. And now we're already in Sam Watch. So now we can tell it, well, here, let's start it off with Is this plugged in? Is this turned on?
It's not plugged in?
Oh, well, here's one thing. Since we are using a physical light that has its own on and off, I don't know which is on and which is off. So we're going to troubleshoot this. We're going to test it. So what we'll do, we'll just look at first, we'll look at Sam Watch in order to see what it's hearing and if it worked. And we'll also look at the console for the Pi. So, hey Snips, turn off the light. Oh, wow. Ha ha ha.
Apparently
it hurt us.
my killing didn't work.
So the Matrix voice setup with this is like 15, 20 feet away.
Yeah, it's pretty far away. This is impressive.
And I wasn't yelling, and it hurt us. That's good job, Snips.
For now, maybe we could change the wake word to Jarvis, like for this one.
That's a good idea.
Yep.
And that shows you how to set up a different wake word. So, well, let me tell it to turn on. Hey, Snips. Oh, now this works. Hey, Snips. Turn on the light. Oh, okay. Interesting. So this heard a bunch of different things. Let me just very quickly change this to Jarvis before we have that happen again. So how you do that is you go into the Snips console here. Let me refresh the page here. Okay, now it's censored properly. You go to like your assistant and then Jarvis. Now you can also do a personal wake word, and to do that you basically need to give it like what, 3 or 5 voice samples of yourself in order to have it recognize like your voice specifically with whatever wake word you want. So if you want it to be potato, if you want it to be like Jeeves or something, or Butler, I don't know, whatever you want, you can do a personal wake word. And last week when we were interviewing the CTO of Snips, he told us something cool, which was, oh, it hurt us. He told us that if you put different people on there, you can assign different wake words to different people, and you'll know when each different person is talking. So let's say you're setting this up in like your smart home, and your like girlfriend or whatever walks in and she says like, hey Snips, or whatever her wake word is. You can have like specific things set up for her. So if she says to turn on the lights, it'll turn them on to like the temperature of the lights that she likes. So it's like a cool customization that you can do. So we're going to put this as Jarvis. We'll deploy the assistant again, copy that, get out of Sam Watch, paste this, wait for that to go. Wow, it hurt it again. Okay, but yeah, this is pretty good so far. I think the codes work. Well, actually, so you didn't see this, but it accidentally triggered. It hurt us. If we like scroll up here, it heard hey Snip somewhere and on. So it actually did. Oh my god. At least oh no, the other one did too. Okay, good. Okay, so this should be good now. Stop. So Sam Watch. Okay. Let me do something. Stop this. Start it. Okay, cool.
Awesome. Okay.
Okay, so now we can do this. So we'll start this off with just the console here so you can see. So, hey Snips.
Or Jarvis.
Jarvis, turn off the lights. Okay, it turned it off. So you can see here, Jarvis, it heard us say it. Where does it say that it heard us say it?
Turn off the lights right there. You just hovered over it. A couple lines down.
Okay.
Yeah. You see it? The light green right below.
Yeah. Okay. So, and it heard us say turn off the lights. Light states. See, yes. Turn off. 100% confidence. And off. And now if we look at the console for the Raspberry Pi, you can see it detected the wake word, and then it set the lights to be turned off. Lights off, and then the session ended. So that works programmatically. Now let's look at it. So let's switch the camera to this one. And here, let me turn off the lights in the room. Hey Snips, turn off the lights.
Amazing.
Haha, that works.
We have 2 demos to show you today.
Yeah. Twofer. Okay, so now we have the Matrix voice here. So, Jarvis, turn on the lights. Ta-da! It did it!
Yay! That's beautiful.
And so that's it.
Wow.
Yeah. And here, this is really bright. Or let me turn on the other lights. Hey, Snips, turn on the lights. I don't know how this hurt us.
Yeah, I think it may have heard some version of Jarvis, but it's
maybe. Okay, so here, let me move the camera back up so you see us. Hi. Here, let me put a little down there. Okay, more or less. Okay, so that is it. You saw set this up, program it, use the Snips console in order to create the assistant, and yeah. So this guide we're going to be releasing either tonight or tomorrow morning. Today is February 6th. So either tonight, tomorrow morning, you'll see it. If you're seeing this in the future, it'll already be out. We'll have the link in the description for the live stream, or you could just go to our Hackster page, hackster.io/Matrix-Labs. And you'll see it there. We'll also be like tweeting at it, so if you're following us on Twitter at Matrix_creator, then you'll see it there. Is there any questions in the live chat for the YouTube?
No questions so far, but there's a lot of like exciting, can't wait for this episode, nice case.
Okay,
wow,
nice.
So positive comments,
awesome.
Good vibes.
Cool.
But,
cool. I feel pretty good. I mean, this was my first one.
Yeah,
like first actual guide. Normally Carlos does it. Carlos is amazing.
Yeah. But no, like it was, very like, nice, smooth, good progression. And
there were no bugs. That's an important thing.
Very important. And it was super fun to see both like the far away, like literally this switch is this light switch is far away, and like close up like of both demos. Yeah. So it was like really nice that worked out. How that worked out.
I'm happy.
Yeah.
Okay, cool. So I guess that's it for the guide. I'm trying to think if we have any announcements.
Do we want to announce who's going to be our speaker for next live stream?
Did they confirm?
Yeah. Well, Alessandro confirmed.
He did.
Yeah.
Okay, so I guess we'll say it now. So Alessandro from ARM, he's their, what's his title?
Good question. Let me look that up real quick, but
in case you don't know, Matrix Labs, Rodolfo, our CEO, he is part of the ARM Innovator Program, and it's this great program that ARM has created.
Developer Advocate.
Okay, cool. Yeah. So Alessandro Grande, and he's a developer advocate for ARM. Super nice guy. We've worked with him a lot, and we worked with him because of the Innovator Program. We do a lot of things with ARM with that. So next week we will be interviewing him, talking to him about the Innovator Program, about the exciting things that ARM is doing, and as well, we mentioned this in the last live stream, the contest.
Oh, yes.
Yeah, so this, ties everything in together. In the next couple months, we will be doing a contest with Snips.ai, ARM, Hackster, and it will be really cool. This guide's kind of prepping you guys for that. So stay tuned for that. And yeah, I'm trying to think. What else announcement?
I think those are the main things.
Yeah,
like stay tuned for the contest. Super exciting. Stay tuned for next week's live stream. And, always keep in mind that if you want, you can get a full package with our Matrix kits on our website.
Yeah, so on our website, matrix.one, you can check out our kits or go to store.matrix.one. We have these kits on a super nice case with like a Matrix Creator, Matrix Voice, with the Raspberry Pi, power supply, micro SD card preloaded with everything already. Our libraries, Raspbian, that way you can just plug it in and it starts working. And we even have a little startup script that runs on the first boot, so it's a little cool thing that you'll see. But yeah, you can get those kits, and that's a really easy way to get started with developing with our devices. Our whole goal is to make hardware easier, so it's a good way of doing that.
Yeah, so I think with that we can wrap up, right?
Yeah. There's no other questions in there?
No, it doesn't seem to be any questions.
Okay, cool.
Yeah,
awesome.
We're all good.
Great.
Awesome. Okay.
Well, thanks for watching, guys. Again, this is Alfred.
Sumrine.
And see you next week. Bye.